Yeah, good morning, students. In the previous class, we had a discussion on arbitrator. So, how these IO devices can perform the communication and do the data transmission uh, in the form of master and slave. So, how these IO devices can act it as a master and a slave? We had a method which we are calling it as a arbitrator. We have seen that. Now, in today's class, we are going to start about the discussion on IO interfacing and as well as this what is meant by serial port and parallel ports that we are going to discuss in today's class. Now, I would like to share my screen. Just bear with me for 1 minute. So, is my screen is visible? Yes. So, the today's classroom discussion topic is based on this interface circuits and parallel interface and serial interface. So the lecture objectives are this session will develop the students' knowledge on differences between the parallel and serial interfaces or parallel and serial ports, how we can differentiate this. So generally the interface circuit, if you take that, basically the IO devices, in the previous class itself we discussed that the IO interface, IO devices are get connected to this single bus. So this is a bus. For example, this is an IO device 1 and this is an IO device 2, like that. These IO devices are connected through some interface which we are calling it as, this is called as an IO interface. So we are already familiar with that. This IO interface will have different components. Generally, this IO interface is having the address decoder component. We have seen that address decoder and as well as this uh, control circuitry will be there. And then the third one we have is different types of registers are there. One is a data register, another one is a control register, and we have the third one is the address register. So we have three different types of registers are there in the IO interface. So these are the three important things already we discussed in the previous class itself. What this IO interface is consisting of. So these IO devices are get connected this via the IO interface. So this IO interface of a device, any IO device, if you take it as so consisting of a circuitry needed to connect the device to the bus. This is what we are calling it as IO interface. That circuitry is called it as an IO interface. So on one side of the interface are the what we are calling it as the bus lines for address and data and control. Just now I discussed here. On the other side are the connections needed to transfer data between the interface and the IO device. So which we are calling it as the port we are calling it as. So and it can be either a parallel or a serial port. That means here for this particular bus here this wire is get connected to this IO device or this IO device is get connected to what we are calling it as. Here we have a port will be there. Here also we have a port. So via the port, by making use of this wire, you are connecting this IO device to this bus basically. So here that is the IO port we are calling it as. So this IO port can be either a parallel port or a serial port. So we are going to see how this parallel port transfers these multiple bits of data. Generally, this parallel port is going to transfer the multiple bits of data from and to the device. Whereas the serial port sends and receives the data one bit at a time. I think you got the point here. So the parallel port and serial port here. So the serial port is able to send and receive one bit at a time, whereas this parallel port is able to send and receive multiple bits of data from and to the device. So more than one bit of data you can send and as well as you can receive at the same time. So that is the communication with the processor is the same for both the formats, but the conversion from a parallel to a serial format and vice versa takes place inside the this IO interface circuit. So we need some sort of conversion is needed from parallel to serial or serial to parallel conversion is needed based on that IO port. So through which we have connected that particular device. So this is an IO interface. What this IO interface circuit will performs. This already we discussed that this IO interface circuit is going to provide a register for temporary storage of the data, which we are calling it as a data register. And then we are this IO interface is also including a status register containing the status information that can be accessed by the processor. And then this IO interface includes a control register that holds the control information, which is used for understanding the behavior of the interface. So these are the three important registers that this IO interface circuit will consisting of that. So along with that, another important components we already discussed about that, which we are calling it as address decoding circuit will be there. So which is used by the IO device when the processor sends the signal or when an IO device sends the data, this requires to decode the data which can be understood by the processor. So address decoding will be there. Then there is also another important uh, hardware unit that we have is to generate the control signals. Okay, control unit will be there, and many format conversions may be necessary to transfer the data between the processor and IO devices. Just now I told na that is a serial to parallel conversion and vice versa. It requires when we require the connection between parallel port to serial port. So that conversion is required here basically. Fine. So now if you take one example here, that is what we are calling it as the keyboard, that is the input interface. If you take it as the most important thing is here, we are taking it as the input device is what we are calling it as a keyboard. So the keyboard is the basic input device here, which we are using that. So if you see that how it will be get connected here, so we have this interface will be there, the input interface will be there. So which we are calling it as these are the two important registers that are present, KBD underscore data and KBD underscore status. These are the two important registers that are present in the input interface. And there is an encoder circuit which is used for whatever the key we are pressing on the keyboard. For example, if you are pressing a capital key, then it has to be converted into its equivalent ASCII character, ASCII code, isn't it? So that will be done by this encoder circuit. Okay. So a typical keyboard is consisting of a mechanical switches will be there here on the keyboard that are normally open. So when you press a key, so it switch closes and establishes a path from the path for an electrical signal. The signal is detected by encoder circuit that generate the ASCII code for the corresponding character. So whatever we are pressing that key, that ASCII code will be generated and its equivalent ASCII code character will be written or stored in the KBD underscore data register to this data bus. And based on this, the status of this keyboard and the status of the key what we have pressed, that information which we are calling it as it is a valid key or not, that information is going to be stored on this KBD underscore status. And this is a this keyboard interface is connected to this processor. Now this processor can able to uh, perform this or read this data from this keyboard input interface. So via the address bus, and this is the data bus will be there, and this is a control signal whether you want to read the data from this or write the operation. So there is a again this master ready and slave ready control signals are used by this processor to know the status of this particular keyboard. Fine. So now here there is a one important problem that can be identified when we are inputting the data. That is the bouncing problem. So the bouncing may last only 1 or 2 milliseconds. So that means this is what we are calling it as when you are pressing the key on the keyboard. So how much rate, at which rate you are pressing the key, and at which rate the data will be received and by the IO interface, keyboard interface, and it is to be processed. There is some sort of time gap is maintained. That is 1 or 2 milliseconds time gap is maintained. So if it is not maintained properly, that then it is resulting it as a bouncing effect. So this bouncing effect can be eliminated using a simple circuit, which we are calling it as a debouncing circuit, which could be a part of the keyboard hardware or maybe incorporated in the encoder circuit. So the speed at which you are pressing the key on the keyboard, it should be there is a time gap of 1 or 2 milliseconds there that will be accommodated here. So the software that detects the key that has been pressed, when it observes that the keyboard status flag key in has been set to 1. So then the IO routine can then introduce sufficient delay before reading the contents of the input buffer KBD underscore data to ensure that bouncing has subsidized. So then when the debouncing is implemented in the hardware, the IO routine can read the input character as soon as it detects that k in is equal to 1. So the parallel interface, which we are calling it as the output of the encoder consisting of one byte of data representing the encoded character and one control signal called valid control signal. So when a key is pressed, the valid signal changes from 0 to 1, causing the ASCII code of the corresponding character to be loaded into the KBD underscore data register, and the status flag k has to be set to 1. So the status flag is clear to 0 when the processor reads this KBD underscore data register. So the bus has one another control line, which we are calling it as a read or write control line, which indicates the read operation when equal to 1. So when R is equal to 1, the processor is going to read the data. So this is another output interface, which we are calling it as. So this is for display device, because it is a standard output device. So here this output interface is consisting of two important registers: disp underscore data register, disp underscore status register. And here we have this processor will make use of the data and as well as the address bus. So by making use of that data and address bus, and this is a control signal R and W, because the processor will write the data whatever that is received from the keyboard, and it will be write the data into this display register by making use of the data and as well as the address, and then the corresponding display device will make use of the data bus to read the data. When it is ready, the display device is ready, it will enable this ready signal. When this data is available in the data register to read, then new data will be enabled here basically. Fine. So this is how it will goes the output operation. So the output interface can be used to connect an output device such as a display device. So the display uses two handshake signals. One is new data and ready. These are two handshake signals. So when the display is ready to accept a character, it asserts its ready signal, which causes the D out flag. Here, data output flag will be there. This is the flag register. Flag bit will be there in the display status register. It will be there. So D out flag will be set to 1. So when IO routine checks D out flag and finds it is equal to 1, it sends a character to the display data. So this clears the D out flag to 0. Once the data is available in the display data register, then it will be set to 0. So and accepts and display the character in display data. Then when it is ready, it is to receive another character, it asserts ready again, and the cycle will be repeated basically. Fine. And then coming to this, how this this input output units are get connected is by making use of either the serial interface or the parallel interface. Okay. So this is a serial input. So we have an input shift register will be there, and this is data in is another important component here, and this is a data out here. This is a serial output register. So this is a serial input register and serial output register, which is a data output here. So here we have a address decoder and control circuit will be there. So in this master ready and slave ready will be there, and these are the address bits will be there. A1, A22, A31 address bits will be used here, and these are status and control registers which will receive the control information basically for this D0 to D7 8 bits are will used here. So here, because these are what we are calling it as a data 8 bits data we are transmitting here. So a serial interface is used to connect the processor to IO device that transmits data one bit at a time. So data are transferred in a bit serial fashion on the device side and in bit parallel fashion on the processor side. Fine. So processor side will be in parallel and device side will be in serial fashion. So the transformation between the parallel and serial formats is achieved with the shift registers that have parallel access capability. Okay. So the shift registers will be used for achieving of the serial to parallel and parallel to serial conversions. Output shift register and input shift register is used for that. So the input shift register accepts the bit serial input for the IO device. When all 8 bits of data have been received, the contents of the shift register are loaded in parallel into the data in register. Similarly, output data in the data out register are transferred to the output shift register, from which the bits are shifted out and sent to the IO device. So two status flags are used here. S shift register S in and S out are maintained by the status and control block. SIN flag is set to 1 when new data are loaded into the data in from the shift register and cleared to 0 when this data are read by the processor. SOut flag indicates that whether the data out register is available. So it is clear to 0 when the processor writes the new data into the data out, and set to 1 when the data transferred from D out to the output shift register. So this is a serial interface. During serial transmission, the receiver needs to know when to shift each bit into its input shift register. Since there is no separate line to carry a clock signal from the transmitter to the receiver, so the timing information needed must be embedded into the transmitted data using encoding scheme itself. So for that particular purpose, we are making use of two important approaches. One is asynchronous transmission and another one is synchronous transmission. These are the two important approaches for transmitting of the data, synchronous and asynchronous transmission. Now we will see the asynchronous transmission. So in this, what we are doing here is that bit by bit we are transmitting that, and we are adding a start bit as well as the one or more stop bits we are adding here to indicate that this is the starting of the actual 8-bit data, and this is the ending of the 8-bit data. So we are adding one or two stop bits and one start bit and one or two stop bits we are adding that. So this approaches uses a technique called it as start and stop transmission. So data are organized in a small group of 6 to 8 bits. Generally, we will make use of 8 bits here. And there is a well designated beginning of the bit and ending of this transmission of 8 bits in a tip. So we are making it as every character we are transmitting that. Every character will be encoded into 8 bits. So a line connecting the transmitter and the receiver is in one state when idle, and a character is transmitted as a 0 bit referred to as the start bit, followed by 8 data bits, and one or two stop bits will be used here. The stop bits have a logic of value 1. So that means here the 1 to 0 transition at the beginning of the start bits alerts the receiver that the data transmission is about to begin, and using its own clock the receiver determines the position of the next 8 bits, which it loads into the input register. The stop bits following the transmitted character, which are equal to 1, ensure that the start bit of the next character will be recognized. So when transmission stops, the line remains in the one state until another character is transmitted. So like that, we are making use of start and stop bits. We are using that. Then next, coming to this, what we are calling it as synchronous transmission. Now, so the receiver generates a clock that is synchronized to that of the transmitter by observing the successive high to low or and low to high. That is 1 to 0 and 0 to 1 transitions in the receiver signal. So it adjusts the position of the active edge of the clock to be in the center of the bit position. So a variety of encoding schemes are there for synchronous transmission are used to ensure that the signal transition occurs to enable the receiver to generate a synchronized clock and maintain the synchronization. So once synchronization is achieved, data transmission can be done continuously. So encoded data are usually transmitted in large blocks consisting of several hundreds or several thousands of bits. So the beginning and ending of the each block are marked by appropriate codes. Okay, so now it is the reflection point. So what is the role of shift register in serial data transmission? Okay, so we are using this shift registers in the serial data transmission, input shift register and output shift register we are using. So the role of this shift register is what? So to achieve at the processor side, to achieve the uh, serial to parallel conversion or parallel to serial conversion. So that is the parallel to serial conversion or serial to parallel conversion. In order to achieve that at the processor side, we will make use of this input shift register as well as output shift register. Right. So now after listening to this now lecture, so this particular lecture will develop the knowledge on the differences between what is the parallel and serial interface. Fine. So now coming to this summary of this today's session. So the summary goes like this here. IO interfaces can be either parallel or serial. Just now we have seen. So parallel interfaces can transmit the number of bits at a time, whereas serial interfaces can transmit one bit at a time. So we are making use of shift registers used in serial interface, so that we are achieving this what we are calling it as parallel to serial and serial to parallel conversion at the processor side. And then transmission in serial interface can be either asynchronous or synchronous transmission. Fine. So these are the concept we have discussed in today's classroom discussion topic. So now this is what the lecture outcome. So after completion of this session, you will be able to compare the synchronous and asynchronous transmissions as well as what is the parallel and serial ports. Fine. So this is what the lecture level practice problem. Now compare synchronous and asynchronous transmission. Fine. So thank you. So any doubts you have in today's class?